Okay kids, we'll be going with the continuation of the previous thing. In the last class we have done work energy power questions. So we'll be doing now some of the circular motion questions, right? So these questions I have picked from NTA app. Yeah, you will understand what does it mean NTA app later. So if you look at the question, a small block of mass m is released from rest from point A inside a smooth hemispherical ball of radius r, which is fixed on the ground. The ratio of magnitude of centripetal force and normal reaction. Centripetal force and normal reaction. So in the question itself they have drawn the free body diagram. If you look at the free body diagram, there will be normal, there will be mg is component this way. When this angle is theta is going to be mg sin theta, and this component is going to be mg cos theta. Yeah, whenever something is performing circular motion, net force towards the center must be equal to mv square by r, right? So n minus mg sin theta equals to mv square by r. So this is circular motion constraint. Now apart from that, if I want to find v, how I can find v? Yeah, I can say this potential energy is 0. I will be taking as reference. Kinetic energy is also 0. Now this potential energy is going to be mg into this height, but negative, right? So minus mg, what is this height? This is r. So this height is going to be r sin theta, So kinetic energy will be going to be plus mg r sin theta, that is half mv square. Kinetic energy equals to mg r sin theta. This is conservation of mechanical energy. Okay, from here, okay, I can find v, right? Okay, they are asking what is the ratio. Okay, let me see. So let me find centripetal acceleration. So what will be centripetal acceleration? V square by r. V square by r from this equation will be 2g sin theta. So that is centripetal acceleration. So centripetal force is mv square by r, which is 2mg sin theta. Now what about normal? If I want to find normal equals to this mg sin theta. When I take to the right hand side, it will become plus mg sin theta plus mv square by r is 2mg sin theta. So normal is turning out to be 3mg sin theta. Normal is 3mg sin theta, centripetal force is 2mg sin theta. The ratio will be this by this, centripetal force by normal. Ratio will be 2 by 3, right? So how that looks, the ratio is constant, right? So it is option A. Going to the next question. The road is banked at an angle 30 degrees to the horizontal for negotiating a curve of radius. See, now what is going to happen is, generally, if this is the road, if this is the road, if the car is going this way, then it's fine. But if car is taking a turn, circular turn, then there must be some force towards the center, right? Now that what can provide it? Only friction can provide it. But if the friction is very less, what will happen? There is a tendency of car to slide away, right? So in order to avoid this, what we will do is, whenever there are circular turns, we don't build the road flat. We will be making some angle theta like this. The road will be made some angle theta with the horizontal. So it's like, generally the road used to be like this, but now we will be tilting it. We will be making the road like this. Now there will be some vehicle here. That vehicle will be taking a turn, so you can visualize it like it's like performing some kind of circular motion. Now if you draw the free body diagram of this block, there will be weight and there will be normal, where this angle is theta. If this angle is theta, this angle will be theta, this angle will be 90 minus theta. So normal's horizontal component will turn out to be n sin theta, normal's vertical component will turn out to be n cos theta. Now what I can say, net force towards the center is mv square by r, that is normal sin theta equals to mv square by r, and it is not accelerating in this direction, so normal cos theta equals to mg. Circular motion constraint, and vertically it is not accelerating, right? Now what they are asking, when the angle is 30 degrees, what will be the velocity, right? So you can take the ratio, so you will be getting tan theta equals to v square by rg. So v square equals to rg tan theta. R is 10 root 3 into g into tan 30 is 1 by root 3. So v will turn out to be 10. V will turn out to be 10 meters per second. 10 meters per second, we need to convert it into kilometers per hour. So that is 10 into 10 power minus 3 kilometer by 1 by 3600, right? So which is (18 5 18 to 36), right? Yes. Going to the next question. A point P moves in counterclockwise direction as shown. The movement of P is such that it sweeps out a length is equal to t cube plus 5. So they are saying like at what rate this length is being covered. So we can find the speed by differentiating it. S is given as t cube plus 5. So when I differentiate, I will get speed which is 3t square. If I further differentiate it, I will get tangential acceleration which is 6t, which is 6t. Now what they are asking, acceleration of P at t equal to 3 seconds. So at t equal to 3 seconds, what is tangential acceleration? Tangential acceleration is 18. What is the velocity? Velocity is 27. If velocity is this much, what will be the centripetal acceleration? When a particle is moving this way, there will be tangential acceleration and centripetal acceleration. Centripetal acceleration will be v square by r, which is 27 square by 27, which is 27. So centripetal acceleration is 27, tangential acceleration is 18. You need to find the total acceleration. Total acceleration will turn out to be square root of centripetal acceleration plus tangential acceleration square, which is, you can take 9 common, 9 into root of 3 square, which is 9, plus 2 square 4. So 9 root 13, which is 9 into root 13, they said it as 3.6. 9 6 are 54, 27, 32.4. A long horizontal rod has a bead which can slide along its length. Initially is at a distance L. There is a rod which is rotating and there is a bead at a distance L from end A. The rod is set into angular motion about A with constant angular acceleration alpha. If the coefficient of friction between the rod and the bead is mu. See, we have seen something like velocity will be given by omega bar cross r bar, magnitude wise r omega or omega into r. Now tangential acceleration we have seen it will turn out to be alpha bar cross r bar. Magnitude wise r alpha. So the thing is, if a bead is rotating, the rod is rotating, when the rod is rotating there is a bead, right? Bead also will rotate with the rod, right? Why the bead will rotate in this direction? Because the rod will try to push the bead in this direction. Now if this is the rod and there is a bead here, rod is, now let me say it is rotating about this axis. So in the later moment rod will be going into the plane, right? Now why it will be going into the plane? There must be some force acting on the rod. What is that? Normal reaction. Normal by the rod on the bead will be into the plane. And how much is that normal reaction? That normal reaction will be given by, will gives us the tangential acceleration, right? Because it is performing circular motion, right? So that normal reaction will give you tangential force, tangential acceleration, mass times of tangential acceleration. What is tangential acceleration? R alpha. What is R? This length. This length is L, they said. So normal will give you the required tangential acceleration. Now it is performing circular motion also. So who will be providing that required centripetal force? How much is that required centripetal force? M omega square R. But who is providing that required centripetal force? Friction, right? Friction. So normal will provide the tangential force, friction will provide the required centripetal force. Now they are asking at what time it will be slipping. So friction must not be sufficient. So friction will turn out to be the critical value, mu into n, right? So for what omega, friction will be just sufficient, we will be seeing it. So mu into n is m omega square L. I can substitute n, right? Mu into m L alpha equals to m omega. How to find omega in terms of alpha? Omega final equals to omega initial plus alpha into t. Omega final equals to 0 plus alpha into t. So omega will turn out to be alpha t, right? Now thereafter we can cancel m L, 1 alpha will go. Okay, anyway I am going to put it there itself. So mu equals to alpha square t square by alpha. So which will be, from here you need to find t. T is how much? Mu by alpha square root. So after this time, till that time it will be performing circular motion, friction will be sufficient to provide that required centripetal force. After this time it is going to slip, right? Going to the next question, you need to find the velocity when the angular velocity and position vector are given. So V bar equals to omega bar cross R bar. Now how to find the cross product? Generally we will be taking this determinant thing, right? I cap, j cap, k cap. Now omega bar 4, 1 and minus 2, that is 2, 3 and minus 3. So how will we be taking the determinant? Plus I cap minus j cap plus k cap. So I cap, when I close this I will be getting 1 into minus 3, which is minus 3, minus of minus 6, which is plus 6. Now j cap, when I close j cap, 4 into minus 3 minus 12, minus 2 into 2 minus 2, so it will be plus 4, 4 into 3 12 minus 2, so which will turn out to be 3 I cap minus of minus plus 8 j cap plus 10 k cap, 3 I cap 8 j cap 10 k cap, 3 I cap 8 j cap 10 k cap. In aircraft loops, an aircraft loops a vertical loop of radius 500 meter with a constant velocity 360 km per hour, which will be 360 into 5 by 18, which is 18 ones 1820, so 100 meters per second. Speed is 100 meters per second. So you need to find the weight of the flyer of mass 70 kg in the lower, upper and middle points of the loop. So when it is here, see there is an aircraft and inside that there is a flyer, right? So what will be the weight of the flyer? You will be placing on the weighing machine. So normal will give us the weight of the flyer. So let us just look at the flyer. How much will be the normal? Normal will give us total centripetal acceleration plus tangential acceleration. But in this particular situation, there will be only centripetal acceleration. Right? Only centripetal force. Yeah. In this case, okay, we'll see one by one. So here the speed is 100. Here the speed is 100, here the speed is 100. So let us try to find mv square by r in the first place. mv square by r will turn out to be how much? M is 70 into v square is 100 square, which is 10 power 4 by r. Okay, I think 100 square I will put, right? 100 into 100 by r is 500. This 0 will go. 5 ones 520. So this is 1400 or 1.4 kilo. Now what about mg? Mg will turn out to be 70g, which is 700 or which is 0.7 kilonewton. Now what about the normal here? Normal here will be this way, mg will be this way. So normal minus mg equals to mv square by r. So from here normal will be mg plus mv square by r. Mg is 0.7 K, mv square by r is 1.4 K. So which will be 2.1 K. At the bottommost point it will be 2.1 K, 2.1 K. Now what about at the topmost point? At the topmost point normal will be downwards, mg also will be downwards. So normal plus mg equals to mv square by r. So normal equals to mv square by r minus mg, which is 1.4 kilo minus 0.7 kilo, which is 0.7 kilo. Now what about this particular position? At this particular position mg will be this way, mg will be this way. Now it is moving the constant velocity, so net force in tangential direction must be 0. Net force in the tangential direction must be 0. Here it is already 0. Here there is no one to pull it, so we are not applying any force. Here also there is no one to pull, so we are not applying any force. But here gravity is trying to pull it down, so we need to apply extra force here, like the friction will be providing that. The friction will be providing that, so which will turn out to be mg. Mg is 0.7 K. And normal must provide centripetal force mv square by r, which is 1.4 K. So generally we say this is the weight, but I think they are trying to ask what is the net reaction force, kind of. So net reaction force will be square root of this square plus this square, which will turn out to be approximately 1.5 kilo Newton. When a ceiling fan is switched off, its angular velocity reduces to 50% of its initial value when it makes 36 rotations. So what does it mean by one rotation? One rotation means the angle rotated is 2 pi radians. 2 pi radians, that is theta is 2 pi radians. So what I can do, I can use this formula, omega final square minus omega initial square equals to 2 alpha theta. Now omega final square, let me say omega initial is omega naught or like omega. So what is happening? Angular velocity is becoming 50% of its initial value, so it will become omega by 2. So omega by 2 whole square will be omega square by 4, which equals to 2 times of angular acceleration here is negative into theta. Theta is how much? 36 times 2 pi radians. One rotation 2 pi radians, 36 rotations, 36 into 2 pi radians. Now what they are saying, if the angular retardation is uniform, then how many more rotations further, how many more rotations will it make before coming to rest? So final angular velocity will be 0, initial angular velocity is omega by 2, right? So from omega to omega by 2 we have written the equation. From omega by 2 to 0 we have to write this equation, just 2 into minus alpha into, let me say the number of rotations are n, so n into 2 pi will be the number of radians, right? So when I take the ratio, this will turn out to be minus 3 by 4 omega square, this will turn out to be minus 1 by 4 equals to 2 minus alpha 2 pi, so 36 by n. So you will be getting 3 equals to 36 by n, so n equals to 12. Further 12 rotations will be happening from omega by 2 to 0, right? A smooth semicircular wire track of radius r is fixed in vertical plane. One end of massless spring of natural length 3r by 4 is attached to lowest point of the wire track. A small ring of mass m which can slide on the track is attached to the other end of the spring. The ring is held stationary at point P such that the spring makes an angle 60 degrees with the vertical. The spring constant is given. Consider the instant release in the normal reaction on the ring by the track. Okay, so let us draw the figure. They said there is this circle and this is the spring. This is the spring where it is making an angle 60 degrees. If this is 60 degrees, this is radius, right? So if this angle is 60, then this angle will be 60, then this angle will be 60. So all the three sides will be same, which is r. So length of the spring is r, but natural length is 3r by 4. So what does that mean? Spring has been extended. Spring has been extended. How much it has extended? R minus 3r by 4, which is r by 4. It has extended by r by 4. So what will be the spring force? Spring force will be kr by 4. Kr by 4. Kr is mg, so spring force is going to be mg by 4. So spring force is going to be mg by 4. Now apart from spring force there will be weight. Weight will be mg. Now apart from that there will be normal. Right? Yeah. Yes. Now the net force towards the center equal to mv square by r. So that is n plus mg by 4 cos 60. Mg by 4 cos 60 is mg by 8 minus mg cos 60 which is mg by 2. Mg cos 60 which is mg by 2 equal to mv square by r which is 0. So normal equals to mg by 2 minus mg by 8 which is 3 mg by 8, right. So centripetal force, if the velocity is 0 then the normal will be balancing the force along that direction. The next question, a block of mass m is placed at the lowest point of smooth vertical track. In this position block is given a horizontal velocity u such that the block is just able to perform complete vertical circular motion. In yesterday's class we have seen if it is performing complete vertical circular motion at the topmost point it must be just able to perform. So the meaning is normal reaction will be 0. So mg will be alone providing that required centripetal force. So we will be writing net force towards the center equal to mv square by r. From there we will be getting at the topmost point the speed is v equals to root rg. So at the topmost point speed is root rg, at the bottommost point speed will turn out to be root 5 rg by energy conservation, by mechanical energy conservation. Okay, the acceleration of the block when its velocity is vertical. When its velocity is vertical, that is this position. At this position, right? At this position, how many accelerations will be there? There will be tangential acceleration. Mg will be there downwards, so tangential acceleration will be g downwards. Now, apart from that, there will be centripetal acceleration. How much will be centripetal acceleration? V square by r. Now, how much will be the speed here? Speed here will turn out to be root of 3 rg by mechanical energy conservation. I think we have done it already. So, if you want, you can do it like from here to here, you can do mechanical energy conservation and you can get the speed as root of 3 rg. So, what will be v square by r? Centripetal acceleration will be v square by r, which is 3 rg by r, which is 3g. Tangential acceleration will be g. So, what is the total acceleration? Total acceleration is square root of centripetal acceleration plus tangential acceleration, which will be g into root of 9 plus 1, which is g root 10. Right? That's the 9th question. Oh, yeah, g root 10. And going to the next question. A stone is tied to a string is rotated in vertical circle. The minimum speed of the stone during a complete vertical circular motion. So they didn't say where it is minimum. So maybe you can take it like at the bottommost point. Okay, bottommost point or topmost point. At the topmost point, what is the minimum speed? Root of rg. At the bottommost point, minimum speed is root of 5 rg. So that is, it is independent of the mass. Is independent of the length? No, it depends on the length. Decreases with increase in length? No, if it increases, length increases, minimum speed will increase. Decreases with increasing in mass of the stone because it is independent, right? It is wrong. A particle in uniform circular motion, the acceleration at point P, r comma theta. So r comma theta, how you will be representing? This is angle theta and this is radius r. So this point is r comma theta. So what will be its x coordinate? X coordinate will be r cos theta, y coordinate will be r sin theta. Anyway, so what will be centripetal acceleration? Centripetal acceleration will be v square by r towards the center. V square by r towards the center. So when I resolve it, I will be getting this is v square by r. This angle is theta, so this angle will be theta. So centripetal acceleration will be v square by r cos theta along negative x axis and v square by r sin theta along negative y axis. So which is this? No, both are negative. So which is this, right? That is one. No, this is, sorry, that is sin theta I cap and this is cos theta I cap and sin theta j cap. Yeah, this is almost the same question. A car is moving in a circular motion which is given by x square plus y square equal to a square. So this is x axis, this is y axis. Now where the radius is a, where this angle is theta, x coordinate is going to be a cos theta and y coordinate is going to be a sin theta. Now unit vector in the direction of friction force, right. So it is performing circular motion in the horizontal plane. So who will provide that required centripetal force? Friction will provide that required centripetal force. Now that centripetal force direction is this way. So let me say direction vector is unit vector, right. So what will be its component? Its component will be 1 cos theta along negative I cap and 1 sin theta along negative j cap. So minus cos theta I cap minus sin theta j cap. Figure below shows a block of mass m connected to ideal string which passes through thin fixed smooth pipe. On the other end, the particle of mass m is connected which revolves in vertical circle of radius r. If the coefficient of friction between m and surface is mu, then what is the minimum value of m? So that the block m complete vertical circular motion. So this must stay there, this must stay there. The meaning is for the maximum tension this must survive, not moving. So when will maximum tension happen? When it is rotating. Maximum tension will happen at the bottommost point. This is performing circular motion, right. So I am just putting it here. So maximum tension will happen at the bottommost point. Yeah, minimum value of m. So we need to make sure that tension has to be minimum here. So we will be giving the minimum speed needed, which is root 5 rg. If the minimum speed is root 5 rg, tension is t upwards, mg downwards. So t minus mg equals to m v square by r. So tension will turn out to be 6 mg. If tension is 6 mg, and if this must not move, so what I can say, tension must be equal to friction, and in the limiting case friction is going to be mu into n, which is mu into capital M into g. Yes, so we need to find capital M, right. So g will go, so this is 2 by 3 equals to 6m, so 2 3s, so capital M equal to 9 times of small m, right. So maximum tension will happen at the bottommost point and the tension will be balanced by the friction. A stone hanging from a massless string of length 15 meter is projected horizontally with a speed 12, the speed of the particle at a point where the tension in the string is equal to twice the weight of the particle. So there is this thing and it is attached to a string and you are giving a velocity 12 to it. Now when it makes some angle theta, okay, let me say some angle theta with the vertical, and the speed is v. Here how many forces will be there? There will be tension, and what they said about the tension is equals to twice the weight of the particle. So tension is 2 mg. Now mg will be there, but I will be taking the component mg cos theta and mg sin theta. Now centripetal force will be 2 mg minus mg cos theta, that equals to mv square by r. This is the centripetal force equation. But there are two unknowns, theta and speed, right. So we need to get one more equation. That equation will be energy conservation, right. Mechanical energy conservation. Potential energy is 0, kinetic energy is half m into 12 square. Now here potential energy will be mg into, this is r cos theta, so this is r minus r cos theta. Kinetic energy will be, you can calculate, I mean this, let me say kinetic energy is k only, or half mv square. So what I can say, initial potential energy is 0 plus initial kinetic energy half m 12 square equals to final potential energy mgr minus mgr cos theta plus final kinetic energy half m v square. Okay, so that's the second equation. So from this is mechanical energy conservation. What we need to find? We need to find speed. So we can eliminate cos theta thing, right? We can eliminate cos theta thing. So mg cos theta, let us find mg cos theta from here. Or let me multiply with r here. I will be getting 2 mgr minus mgr cos theta. What is mgr cos theta from here? Mgr cos theta from here will be 72 72m minus half mv square minus mgr. It will be minus 72m plus half mv square plus mgr equals to mgr cos theta. Mgr cos theta equals to mgr plus half mv square minus 72m. So I can substitute it back. So I will be getting 2 mgr minus mgr cos theta. Mgr minus mgr cos theta will be plus 72m minus half mv square minus mgr equals to mv square. Okay, I can cut m. So finally I will be ending up with 3 by 2 v square. 3 by 2 v square equals to gr plus 72. Gr plus 72. Okay, g into r is going to be how much? 150. Yeah, v square is going to be 2 by 3 times of 150 plus 72. You can calculate the value. So the value will turn out to be approximately 7, which is 4 root 3. Will you be getting 4 root 3? $150 plus 72 is 222. Will 222 go with 3? Tension is equals to weight. I have taken 2 times of the weight. Tension is equals to weight mg. This is mg. Then what is going to happen? This mgr and this mgr will cut. So you will be getting 72, 3 ones, 3 20 ones, root of 42. Root of 42 will be approximately 7, right? Root of 42. Sorry, 3 4. So root of 48. Root of 48 will be approximately 7. Yeah, this is the mistake I did. So, but anyway, what are the 2 equations you have to write? This is one equation, mechanical energy conservation, and this is other equation, which is centripetal force equation, right? Now going to the next question. A particle of mass m is released from a height h on a smooth curved surface which ends into vertical loop of radius r if h equals to 2r. Now if this length is 2r, what is the potential energy here? Potential energy here is going to be mg into 2r. What is the kinetic energy? 0. So what is the potential energy here? 0. What is the kinetic energy? Kinetic energy will be mgr. So what is the speed at the bottommost point? I can write the same thing as root of 2rg whole square. Sorry, mg into 2r, right? Oh. Okay, let me say kinetic energy is half mu square. So I can say initial mechanical energy, which is mgr plus 0 equals to 0 plus half mu square. So mg into 2r. So u equals to root of 4rg. Root of 4rg. So what we understood, this velocity is root of 4rg. So we know if it has to cross this one, the minimum speed needed has to be root of 2rg. It is more than root of 2rg, but it is less than root of 5rg. So what is going to happen? It is going to come into this quarter, right? So if you give less than root 2rg, then it would have been in this. If you would have given more than root of 5rg, it would have performed full circular motion. Now because of that condition, like root of 4rg, it will come into this segment. A particle reaches the top of the particle with 0 velocity. It won't reach the top because it will be performing projectile motion maybe. But if it has to reach the top, we must give at least minimum of root 5rg. The particle reaches the top with non-zero velocity. It won't reach in the first place. particle breaks off at a height h equal to r. See, here it won't break, it will go into that part. So there is a possibility of breaking off in the second quarter. If it is breaking off, it must break off only in the second quarter, right? In the figure, a particle is placed at highest point on smooth sphere of radius r. It is given a slight push, then it leaves the sphere at B. So what does it mean by leaving the sphere at B? There will be, normal will become 0 at this instant. So weight will be there. Let me say this angle is theta. So if weight is there, then weight's component in this direction will turn out to be, this angle will be theta. So weight's component in this direction will turn out to be mg cos theta, weight's component in this direction will turn out to be mg sin theta, and speed will be in this direction. Normal will turn out to be 0. So at that particular moment, centripetal force will be provided by mg cos theta. Mg cos theta equals to mv square by r. This is circular motion constraint. But there are two variables, cos theta and v square, right? So we'll be using mechanical energy conservation. What is mechanical energy conservation? I will take this potential energy as 0, kinetic energy is also 0. What is the potential energy here? Minus mgh. Kinetic energy, let me say it is half m v square. So what I can say, 0 plus 0 equals to minus mgh plus half m v square. So this is mechanical energy conservation. From here I can find v square equals to 2gh. So if I substitute it back, I will be getting mg cos theta equals to m by r into v square is 2gh. G, m. So cos theta is 2h by r. Now what is cos theta from this figure? This is r minus h. This is r, this is h. So this is r minus h. Cos theta is r minus h by r. R minus h by r equals to 2h by r. R and r will go. So r equals to 3h, h equals to r by 3. R by 3, h equals to r by 3. Going to the next question. A block of mass m is placed on vertical circular track. Then it is given a velocity v along the track. The coefficient of friction between the block and the track varies with angle theta. If the block moves on track with constant speed, what does it mean by constant speed? Tangential acceleration must be 0. So at this particular moment, when we resolve the forces, there will be mg. Mg's this component will turn out to be mg cos theta, and mg's this component will turn out to be mg sin theta, and there will be normal. But they said speed is not going to change. So centripetal acceleration must be, tangential acceleration must be 0. What does that mean? Friction must be in this direction, which must be opposing it, right? So what we can say? We can say friction must be balancing mg sin theta. Friction must be balancing mg sin theta, and it is moving, right? So friction will be its maximum value, which will be mu into n. Now we need to find n. How we can find n? Centripetal force, that is n minus mg cos theta equals to mv square by r. So n equals to mg cos theta plus mv square by r. So when I substitute it, I will be getting mu into mg cos theta plus mv square by r equals to mg sin theta. So mu will be equals to sin theta by cos theta plus v square by r g. Sin theta by cos theta plus v square by r g. So option B. Right. So these are some of the questions from NTA app, NTA Abhyas app. So that's the thing. Work energy power, circular motion, and work energy power, there are like 4-5 points. In circular motion, you need to majorly concentrate on 2 points. That is, what is the role of centripetal acceleration, what is the role of tangential acceleration. Combining these two, okay, fine. It's like radius of curvature. How we define radius of curvature? In circular motion, what we said, if velocity is this way and if acceleration is this way, then resolve the acceleration into 2 components. That is, this component is going to be tangential, this component is going to be centripetal, right? That's what we said, right? Now the simplest example is, if someone asks you in a projectile motion, if you are projecting with a speed u at an angle theta, what is the radius of curvature at the topmost point? At the topmost point, speed is going to be u cos theta, because horizontal speed won't change. At the topmost point, acceleration is g in the downward direction. Now these two are perpendicular, so centripetal acceleration is g, right? So centripetal acceleration equal to v square by r. So radius of curvature at the topmost point will be u square cos square by g. So if you see that point is a part of a circle, what is the radius of that circle? It will be this much. But if they ask you what is the radius of curvature at initial point, what you are going to do? Resolve this acceleration into two components. One is along the velocity, one is perpendicular to the velocity. What is perpendicular to the velocity? This is theta, this is 90 minus theta, this is theta. So this will be g cos theta and this will be g sin theta. Now centripetal acceleration is g cos theta. So if it is part of a circle, then I can say centripetal acceleration equals to u square by r. So r initially will be u square by g cos theta, right? So radius of curvature, in physics we have only one way to find radius of curvature, that is by using centripetal acceleration equal to v square by r, right? Thank you.